Hello students, today in your geometry class we're going to be working on proving similar triangles. So before we start, let's look over two theorems and the following postulate. Now theorem 7.1 states that we have the side angle side similarity theorem. Notice how it's denoted by SAS, then the similar sign, which is the tilde or the enye. Now keep in mind the angle is still in between the two sides. This is just proving that things are similar. And it states that if an angle of one triangle is congruent to an angle of a second triangle, and the sides including the two angles are proportional, then the triangles are similar. So all they're really saying here is that if we were to have, say, two triangles, and one of those angles, or the angles are congruent, these two angles say are congruent, and the sides, say x and y, are proportional to A and B, then these two triangles are similar. Notice how we have x and a. These are the sides that include the angle, and y and b include the same ones. So that's theorem 7.1. Theorem 7.2 states the side-side-side similarity, which essentially states that if the corresponding sides of two triangles are proportional, then the triangles are similar. So again, let's use these same two triangles. And this mentions nothing of angles. All it's really saying here is that if we have A, B, and C, and X, Y, and Z, what this is saying is that if these triangles are proportional to one another, for example, A divided by B is equal to B divided by Y is equal to C divided by Z, then these two triangles are similar. So let's look at the last thing, which is postulate 7.1. It states the angle-angle similarity postulate, which says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So notice in the picture, it says that angle R is congruent to angle L, and angle T is congruent to angle P. Notice that they only mention two angles. Mentioning the third would be a little redundant because obviously if these are the same, then angle S and M must be the same also. So we only denote it by angle-angle similarity. So let's practice a couple. Example 1 says, can you conclude that the triangles are similar? If so, write a similarity statement and name the postulate or theorem you used. So before we even start, let's look at what's given. In here they give us an angle and they give us two sides. So theoretically, we want to test to see if this is side angle side similarity. And if you look carefully at what they've given us, on triangle XYZ, they give us a side, the included angle, and this other side. Notice how the angle is in between the two sides, so this one would work. However, in triangle SRT, the 8 and the 10 are not, or the angle is not in between the two sides given. Therefore, this is not similar because side angle side similarity does not apply. Let's try another example. In example 2, it mentions, are the triangles similar? If so, write the similarity statement. So let's look at example 2. We're going to enlarge it really quick just to make it a little easier to see. Notice how it states that we have two lines that are parallel. So let's start with what we know. Because these lines are parallel, then we know that this angle and this angle are congruent because of alternate interior angles. But with that said, we also know that these two angles are also similar, are congruent because of alternate interior angles. Therefore, these must be congruent because of angle-angle similarity. For example 3, let's look at what we have. It says, are these two triangles similar? So we're going to look at these as two separate triangles just to make this easier. The first triangle is going to be this one right here up top. So I know it's not exact, but you get the idea. And that's going to be, based on what they gave us, 20 and 25. Then we're going to look at the larger triangle, which is this one right here, which this side gives us 45 by 55. And obviously this angle, these two angles are going to be congruent because they are the same angle. So theoretically we have side angle side similarity, but we're going to test it. So the ratio between 20 and 25, and 45, the two left sides of the smaller triangle and the bigger triangle, and 25 to 55, when we reduce the 20 45ths, this turns out to be 4/9 because they both have a 5 in common. When we do the same thing here, this turns out to be 5/11. Now, because these two do not have the same proportionality, then this is not similar. And again, these two would be similar if the 4/9 and the 5/11, if those ratios actually reduce to the same number. So let's look at example 4. Same idea, so I'm going to steal these mini triangles. Have this guy and this one to represent the respective smaller triangle and large one. This is 8 and 8. This is 18 and 18. Notice it's 18 though because it's the full length of NQ. And if we look at their ratios, that's 8 to 18 for the left side and 8 to 18 for the right side. And notice that they are the same. Therefore, in example 4, we have side angle side similarity. Moving on to example 5 and 6. This one is going to require us to actually calculate a couple things here, which shouldn't be that bad. So first thing we want to do is we want to look at the two triangles that they give us here. Notice that they're kind of shaped in a different direction, so just to make it easier for us to see, we're going to copy them really quick. Okay, so we have the smaller triangle, which has the 5/3, and we recreated the larger triangle, which we turn right side up so it's facing the same direction. The hypotenuse turns out to be x, and the base turns out to be 4.5. And of course we have our right angle. So we're going to compare these two triangles. So they have the possibility to be side angle side similarity, but again, and they are telling us it's similar, so we just have to write the appropriate ratio. So we're going to do the hypotenuse divided by the base of the smaller triangle, and we're going to say that is equal to the hypotenuse divided by the base of the larger triangle. Then we're going to take the cross product here. This turns out to be 3x equals 5 times 4.5. This turns out to be 3x equals 45 halves. Then we're going to divide 3 to both sides. We're going to get x equals 15 halves. So that's the answer. We're going to try example 6. Now in this one they pretty much give you the same exact scenario, except you're here and you are supposed to calculate the height of the giraffe. So we'll enlarge this so it's easier to see. And we're going to start setting up our shape. So we're going to choose the height of the person, which just happens to be 5'3". So 5'3", we're going to convert into all feet instead of feet and inches. So that turns out to be 5 1/4 feet. divided by 5 because of the distance from the person to the mirror equals, notice again, 5 1/4 is the height, 5 is the length in the horizontal. Then we're going to do the same thing with the giraffe. The height we don't know, and we're going to divide that by the distance to the mirror, which is 15 feet. We're going to do a quick cross multiply. We're left with 5x equals 5 1/4 times 15. Divide by 5 to both sides. We get 15 3/4 as the height. Now it's your turn. Try these 3 problems. Post your answers to Edmodo. First person will start. Everyone else will just reply. That's all for now. See you guys next time.